So one thing you're going to learn is that my drawing skills are kind of lacking. But we'll just pretend that all three of these things are complete circles. Even complete circles. And while we are just going to start getting into this week, I want to jump ahead because I think part of the difficulty in envisioning where our force vectors are isn't related to difficulty in understanding how we calculate force between two different charges and the distance between them. It comes from deciding which way my force vectors go in general. So let's take a look at this a couple of different ways. So first, I want to look at this first charge, and the question I want to ask myself is what direction is the net force on this charge from these two charges? And the important thing here is to remember when we look at this, first thing I do is I take one of those charges away. So I'm going to focus just on these two. And I'm going to hold my finger on this charge. Again, I'm not looking at that one. And I'm going to say, what happens when I lift my finger up off of this charge? What direction is it going to go? And as we'll discuss in class, unlike charges are attracted to each other. So this would be like opposite ends of a magnet. These two things are attracted to each other. So if I'm holding this steady and then suddenly going to let it go, and I'm only looking at what's happening here, then I can see, okay, it's going to go in that direction. So if I label these, we'll call this 1, 2, and 3. If I lift my finger up, this is going to have a force vector going in that direction. And let's go ahead and label that. So I have force 1, 2. So the force related to the charge 1 relative to charge 2. Now remember, we have a couple things in physics, equal and opposite forces. So whatever force 1 experiences from 2, 2 also experiences from 1. So it doesn't matter if I write this as 1, 2 or 2, 1. But in this particular question, I'm saying, okay, so let's think about what's happening just to 1 relative to 2 and 3. So we've done 2. So now let's take out this one and then look at specifically what's happening to 1 relative to charge 3. Now that's a little bit further away, and they're both equal signs and magnitude. So this part will be the same, but this one, let's say if we call this a distance of r and r, this is going to be r, or 2r, or 1/4 the amount of force. So actually, let's go ahead and make this a little bit bigger so this is obvious. Let's say that its force vector is like that. Then the force vector 1, 3 is only going to be about 1/4 of that of 1, 2. So now it's just tip to tail adding. If we look at for the resultant force on that, it's going to be the sum of this component plus this component. So now let's kind of redraw this and draw the exact same thing. And again, these are perfect circles, and these are equidistance apart. So this is r and this is r. Okay? And now I want to know, I'm going to call this 1, this 2, and this 3. What's happening? What force vectors is this number 2 experiencing, this charge 2? So we're going to do the same thing. I'm going to ignore what's happening to the right, and I'm going to look at just what's happening to the left. And again, I'm going to put my finger on this charge and ask myself, what direction is it going to go when I lift my finger up? And when I would lift my finger up, it is going to be attracted to the left. So this would be my force vector, force 1, 2. And then this is the one that gets everybody, because you're like, oh, I have a positive here and a negative here, equal and opposite directions. Therefore, this whole thing is going to sum to 0. So this is where it becomes really important that we ignore what's going on here. And again, I'm going to look at this charge 2, which is a negative charge. And I say, okay, now I put this next to another negative charge. What's going to happen when I lift my finger up? It's going to be repulsed by this charge. So I lift my finger up, and it's also going to flee in this direction. force 1, 3. Let's make that clear. 1, 3. So I end up again with two tip-to-tail additions between these two charges here and these two charges here. Huh. So what happens, let's move it down. Let's look at number 3. I'm going to redraw my perfect circles, my perfect line, equidistant apart, R and R, and go ahead and label them again, 1, 2, and 3. And so I'm going to do the same thing. I'm just going to start and look at what's happening to the left of this number 3 charge. So just looking relative to number 2, what happens if I lift my finger up off of number 3? It's going to be repulsed. It's going to go away from charge 2. So this is force 2 on 3. Now I look, I'm like, okay, so let's take this one away. What's happening between this negative charge and this positive charge? So if I take my finger up off that, it's actually attracted to that direction. So I'm going to have a force vector going this way. So this would be force 1, 3. Now let's go back to this equation. I want to know, are these two equal and opposite and canceling each other out? Pause for a second and answer that question to yourself. Okay, good. So hopefully you do the same thing. This is going to be 2r, where this was only r. So this is over r squared, where this is over 4r squared. So this is a quarter the size of this one. So let's go ahead and make this one again a little more obvious, going this direction. So it's got a larger magnitude going that way. And now I look and I'm like, well, okay, that's more or less a quarter of the size of that. Maybe take a little bit off. Take a little bit off that guy. So 5, F force 1, 3. So I'm going to have a small amount of this canceling out because I do have a force vector going in this direction. But my net force on this charge is going to be in that direction. So if you chew on that, between that and what we're going to do in class, I think you're going to be helped out when we look at this, when we start putting things on a square, and you can do it.